Steve already introduced me, but just to reiterate, I currently teach at Georgia Tech. I teach at Georgia Tech and I work at RedMonk right now. When you are teaching a college class, you do not want to walk in partway through the semester and tell your students, bye, got another job. And RedMonk has been kind enough to let me finish out my semester with my students, for which I am very grateful. And my students don't even know that this was even going to be an issue, because I didn't want to panic them, because they are Georgia Tech students. They are perfectionists as it is. So I am currently a visiting lecturer there. I was formerly on a postdoctoral fellowship, so you'll hear me talk about this fellowship a little bit as we kind of go on, because it actually has to do with the kind of teaching that I'll be talking about. And then of course, I am also now at RedMonk, so I did 2 title slides to make sure I covered all my bases. Right, but back to Georgia Tech, because that's what we're going to be talking about today. So a little bit of data about Georgia Tech. I won't read it for you. I actually did not even know this until I went to put this slide together, that we had over 32,000 students. That number kind of astounded me. Half of them, and only about half of them, are undergraduates. Undergraduates are what I teach. I don't teach graduate students. And in particular, I teach undergraduate students who are majoring in computer science and a slightly different major called computational media. The computer science majors are all kind of under the College of Computing in terms of like the structure of Georgia Tech. The computational media students are split between the College of Computing, and we also have some that also are doing a computational media degree under the School of Literature, Media, and Communication, which is like the Ivan Allen College of Liberal Arts. So that's an interesting kind of split, kind of already. So that's who we'll be kind of talking about today. Now, the students who take one of these majors, they do have the ability to somewhat customize their experience through this use of what we call threads. So our students have certain kind of core classes they have to take for the computer science curriculum. Ethics is one of them. They have an ethics requirement, which is really good. I wish our freshmen also had an ethics requirement, so they had to like before and after. But then, depending on what thread they do, they pick 2 threads, and then it's almost like kind of mix and match customization of those classes. In addition to the threads, which help them kind of figure out where they want to aim, in their career, they also need to fulfill one of these kind of design requirements, and there are 4 ways they can do it. One is through what we call a vertically integrated project, which is really cool, where undergraduates are working over multiple semesters with research faculty to do a particular project. This is something that's not just in the College of Computing, but other different parts of the university do that as well. There's a research option for students who want to do a research thesis. There's something new that we started recently called CreateX, which is almost like kind of simulating how you would do a startup, take a startup idea from design to kind of prototype. And then there's the computer science junior design implementation and computer science technical communication track, which is what the majority of our students actually do. And that's what we're going to kind of look at today. This is the classes that I teach are involved in this track. This is aimed at students who are planning to go out and take industry jobs, but have not necessarily decided they want to do that kind of like startup track. And so we get students coming in who plan to go out and do all types of things, from something like product management to UI design to coding, and the like. So we have a really good mix of very smart students. And in case I don't say it enough, my students are brilliant. If there's any point where we're going through this and it seems that I am frustrated with them in any way, I'm not. They are in and of themselves lovely to work with, and also just very, very smart. So a little bit about the course sequence that I teach. It was initially 2 separate courses. It was initially about 6 years ago. It was run as Computer Science 4911, which was a typical 1-semester senior capstone course, and then combined with another requirement that they also take 3 credits of technical communication. We're going to talk about communication a lot, so this talk following Emily's talk is brilliant in so many ways. Thank you, Steve, for your organizing of these talks. Back to 4911, it was a team-based project kind of course where the students would basically meet with the professor at the beginning of the semester a few times, and it was then very kind of heavily code intensive, right? And then their technical communication would be a completely separate course, that was generic technical communication. Now, issues with this is there was only one semester to do design and implementation of this project, right? The generic technical communication course that they had to take completely separately was not geared toward computer science as a field. It was just technical communication, completely vanilla version. And also, and this is probably the kind of feedback that we got from alumni was very important in making us change this, is that alumni kind of came back to us and said, well, what we're hearing from our employers and we're seeing is that Georgia Tech computer science majors, we really know how to code, we don't know how to write, and we need to fix that. And of course, the result being that we decided to do a combined course sequence that took the junior design and implementation and combined it with a very specific version of technical communication, to the point where these courses are actually taught as co-requisites with two kind of co-instructors. So the way it works is that students register for 2 classes each semester. It's like 1 credit for computer science one semester, 2 for the other. But it ends up being the same number of credits they had in the old system, but just kind of spread out a little bit more. How it now works is we have teams of 4 to 6 students, right? We have real-world clients. Some of these, and we can talk about, we'll see some other clients and projects later, but one of our best clients, entities that do multiple types of sponsored projects with our students, is the Georgia Tech Police Department. And that picture you see there is from a public expo that we did in April. They showed up at this expo not just to see what their student teams did, and they had multiple ones there, but they showed up with like banners and swags for them to use like in their presentation, which was absolutely fantastic. And one of the kind of apps or projects that they were doing actually involved a drone, so we had a drone flying around the expo as well. It's a very, very kind of fun class. In terms of what each class tries to get to by the end of the semester is that by the end of the first semester, we're aiming for students to have a prototype, and they do kind of in-class group presentation about the prototype and how they got to the prototype. And by the end of the second semester, ideally they have a finished application that is at least an MVP. Hopefully they also get some stretch goals in there. And then they do the public exposition. And yes, that is me in virtual reality glasses. It totally ruined my hair that day, but it was for a game called the Archaic Tower that my students built, and it was awesome. It was like being Harry Potter, virtual reality. I love that job. I love my job now too, but this is also very fun. So how do we teach this class? So I mentioned it was a co-requisite kind of structure. Each class actually has 1 LMC instructor and 1 computer science instructor. LMC, School of Literature, Media, and Communication. That's what Georgia Tech has instead of, say, an English department, right? And then 1 CS instructor. Co-instructors, we share grading and lecturing. We do, kind of like all of the main deliverables. We coordinate them across all sections of the course so that one section of the course isn't doing, vision statements. The other one was like, oh, we don't need vision statements. No one needs those. No one needs user stories. So not only are we coordinating between the LMC department and the computer science department, we're coordinating with instructors at the class level, and then we are making sure that all sections of the course are somehow all on the same page, especially when we're going from part 1 of the course to part 2 of the course, to make sure that students get what they need done in part 1 to succeed in part 2 of the course. Okay? And then going back to what I had mentioned earlier, I had mentioned that I previously had been a postdoc. The faculty for these classes come from, on the computer science side, Georgia Tech has something called the Division of Computing Instruction, and they're all lecturers, so lecturers, senior lecturers teaching these classes. So it's not grad students who are usually getting thrown into this. And then on the LMC side, all either postdoctoral fellows or lecturers who also have their doctorate. So this is not the type of class where we just throw grad students in for fun and make them cry at all. And just again, so I'm not leaving anyone out. So the co-instructor that I have up there, his name is Bob Waters. He's the co-instructor that I'm teaching with currently. He has been at Georgia Tech for quite a while. He was a lieutenant colonel in the Army. He flew like helicopters, and then when he retired from that, he's like, oh, I'll go get a PhD. and he did, and then now he teaches at Georgia Tech. So it's kind of like his retirement was like my job. It's kind of insane. He is fantastic. He was actually there throughout the changeover from the 2 separate course model to the kind of combined co-requisite model. We have made changes to the course even while I was there, and we'll talk about those in a little bit. But one of the great things about Bob is in academia and even in tech, I have seen people who don't like when you change their things, like they don't want their darling kind of program change. And Bob is not like that at all. He's very very gracious about when we come in and say, well, this is good, but maybe we could consider this, right? So he's very open to that. And just to make sure I'm not leaving out any of my other co-instructors, I have taught this course with a number of other co-instructors who are all actually very excellent. I will say that one thing I have noticed is that we all like donuts. So like even if it's a bad day, we're having a meeting, it's a little rough, if we have donuts, like it's fine. We can always bring it back to some type of kind of common ground, right? So I've talked a bit about the program, I've talked a bit about the instructors who teach it. What you're going to get now is kind of coming from my perspective. So I think it's important for you to know a little bit more about me and a little bit more about my students, right? So about me, and the most important thing that you need to know about me is that my first gaming system was the Nintendo Entertainment System, the NES, the original one, right? Other things that may be of import, I actually have degrees in English and medieval studies, so I am teaching computer science majors, but I am not, I never had a computer science degree experience, which I understand a lot of people in tech don't. And one thing I do want to point out is that I recognize that getting an undergraduate degree in computer science is not the only path to tech. And our students know this too, but they have chosen this as their path to tech, right? It's the one that they want to take. Another fun fact about me is that I taught my first university class in 2002. Keep that number in your head. Don't do any math with that yet. But later, we'll do some math. And that my first computer was a Commodore 64. And yes, that is a megahertz that we're looking at for the CPU there, right? So let's talk a little bit about my students, right? So my students' first gaming systems were probably a PS2, maybe a 3, maybe an Xbox, maybe a Nintendo Wii, right? They are getting degrees in computer science and computational media, right? They were born in 1997 to 2000 for the most part, right? You're doing that math now, aren't you? Right? Their first computers were probably a Mac or something with Windows, and are in around 2004, 1.3 gigahertz was probably an average CPU, right? So right there, the math should makes me frightened when I think of the difference between me and my students. And of course, whereas the first program language I remember was BASIC, right? Who knows what they've started with? There's like a whole variety of things that are used now. Probably Python, who knows, I don't know. So moving on, and kind of looking at these differences between me and my students kind of lined up, and if it helps, I can give you that visual, right? The one I kind of want to focus on is this, right? That I started teaching college in 2002 when some of my students were too, right? So what we are looking at here is a difference in generations, right? This is the Pew Research Center has put out a kind of definition of generations, but you get different definitions from different authorities and different arguments for what is what, right? This is the kind of standard one where it looks at kind of baby boomers, Generation X, millennials, and then what comes after millennials. We don't know. Post-millennial is what I'm going with now, but I've heard this generation referred to as Generation Z, Zennials, but then Zennials is also used for, there's apparently a generation between Generation X and millennials, and it's very confusing. So I'm sticking with post-millennial, right? But if we go back to me and my students, basically, I'm a Generation Xer, in case you haven't done the math, and they are post-millennials. Even my seniors kind of fall into that category at this point, right? So in order to help kind of kind of point out and illustrate some of the differences between what it's like to like start college having grown up in the era that post-millennials have grown up in. I'm going to have some list of items and the ages that my students were when they came out, right? A lot of Java programmers are out there like, no. The most important take from this slide is that my students have never lived in a world where Star Wars Episode 1 didn't happen, right? And I didn't have to deal with that until I was much older, right? A second round of slightly more recent ones, right? Which is almost worse, right? So even think of even something like Kubernetes. Right? My freshmen were 14 when that. So when they were starting high school, this is a technology that is fairly recent, but they had it through like their high school years, right? So very different, kind of like cultural expectations, very different relationship to technology than I had, certainly. And that actually leads to a lot of challenges in the classroom, which I'm going to kind of talk about now. So first, we'll start with this one, right? The kind of developer culture stereotypes that come out of popular culture actually affect our students in ways that I had not even thought about until I started teaching this class a couple years ago, right? But for instance, the hacking and drinking scene from The Social Network, the idea that programming should somehow be, revolving around this type of party culture, is not necessarily a healthy thing that you want to instill in college-age students, right? As an aside, and we will come back to this, that scene itself, if you've ever looked at it in terms of gender dynamics, you have all of these guys sitting around coding and drinking, and women like walking around the table pouring shots for them, right? And when I play that scene for my students, they do pick up on that. Right? They're like, what is this? So there's the hacking and drinking and then all the other stuff that kind of goes with it. On the flip side of that, there is the 130-hour work week myth, right? That you should not be sleeping. You should always be coding. These are my students. They are A students, right? They are really, really bright. Our library is open 24 hours. They already have, even without like external pressures that go with like software development and developer culture, they already are probably like overworking themselves. But then to like have this kind of external cultural idea that you should never be sleeping, that you always do your best work when you haven't slept in 3 weeks, can be again harmful for them. And then, if you have not seen Silicon Valley, the HBO show, I play this clip, which I won't play because I never think sound happens here. When I play this, what happens in the scene is there is a CEO of a company who is looking out of the window, and he's talking about programmers. It's like, oh my God, they always walk in groups of 5, and then he makes a number of pretty horrible racial and visual and like gendered like remarks about these groups of 5. Right? Now, when I play this for my students, without fail, one of my teams, who are usually groups of 5, will be like, oh, that's us, right? It's never a team with like a woman on it, right? And then what also happens is there's another part of my class that's watching this that's being like, oh my God, I don't see myself there at all, right? And it's funny to see this, and it's funny to kind of laugh at it. Silicon Valley is, in fact, it's like a satire, right? But it is playing on these kind of social stereotypes that, again, my students, they see them, they feel them, right? Which takes me to my kind of next challenge of teaching this class. This is a bar chart taken from, Georgia Tech actually has this really good online fact book. So if you ever want to go look at their fact book and just like, you can create your charts from whatever criteria that you want and see what Georgia Tech students are majoring in and all the other type of stuff. But what this is a breakdown of our undergraduate students by major, or actually by college, right? So, and then by gender, the one all the way to your left is the College of Computing, and you can see how much blue is in there compared to, say, the yellow. Georgia Tech itself is attempting to achieve a slightly healthier gender balance. The College of Computing is farther behind that, and as you can see, there are other schools such as some of the other colleges are a little bit better with that as well. On a side note, you can also run the same search from the Georgia Tech fact book on ethnicity. And this is how students identify themselves as well, which is another thing to point out. And Georgia Tech doesn't necessarily give them that many categories, so especially for gender, it's like very binary, or you either identify as male or female. So that's almost like another problem with how these categories are kind of imposed upon our students in different ways, right? So, another set of challenges: how my students perceive me and my co-instructor in the classroom. Right? When I stand up in front of a class with Bob, many of my students assume I am the TA, and I am not the TA. And Bob does not treat me like a TA, which is wonderful. In fact, sometime in the second week of school, so the first week our students are just so freaked out about teams and iteration plans, which is good. They should be freaking out about their iteration plan at that point. Bob will say something like, and when you send an email to us, or when you send us a memo, or whatever you do, I don't want to be seeing any emails to Dr. Fitzpatrick and Bob, right? Which is very gracious of him, because of course what we normally get is Dr. Waters and Kelly, right? I once had a student refer to me as that lady teacher. Like, really? So that happens, and the other kind of clear almost imbalance is that I am not the computer science instructor. I'm basically the equivalent of the English instructor. I'm the technical communication instructor, and for some of my students, it's just not the most. They don't think that's important, right? Which is, I think I might need to make like a video of Emily's presentation a mandatory viewing for my students, because they don't realize how important communication is for them to do well in their jobs, right? Of course, perceptions of me and my co-instructors change depending on who I'm teaching with. So my students will kind of treat me differently if I'm teaching with Fisayo or if I'm teaching with Mary. But there's always something that kind of comes up. And of course, we actually are human beings and individuals and interact with each other differently too. So that there's that as well, right? So last set of challenges in teaching this class, the changing role of technology. Who here, when they were an undergrad, were allowed to bring a cell phone to class? Exactly. Yes. So when I started teaching in 2002, cell phones existed, but the general rule was that you did not bring your cell phone to class. You did not have it out, or you certainly didn't answer it, right? And usually the same thing with laptops. It was often seen as a distraction in the classroom. Now, students are required to own laptops. We require them to bring their laptops to class, right? They're on there slacking about whatever I just said to their team. So like anytime a group over there laughs, I'm like, are they laughing at me in a good way or a bad way? Like you never know. And you cannot tell students to not bring their phones to class, because they actually get too anxious if they're not able to at least touch their phones. Like you cannot do it. Like policy-wise, you cannot forbid cell phones. Now there are good things that come out about this in terms of especially accessibility, right? We probably should never have banned laptops, from the classroom, because laptops enable things that could not be done before we had them, right? So some of these changes are good. I don't know if social media is a good change for the classroom, but it's definitely one that has affected change in the classroom. My students sometimes use Facebook Messenger as a communication tool instead of Slack. And I don't know why. Like you need to you need to get off Facebook. But also, that whole kind of culture and what that entails. For instance, my department has various social media accounts, and we use them to reach our students in different ways for like different events, which is can be good. Also, the changing role of internships and co-ops. Students miss class all the time because they're going on job interviews. They're looking, to get a co-op. They're looking to get an internship. Right? Some of my students already have jobs at Google, and they have to finish my class to get to it, and that's always fun. right? Like, I'm going to work at Google. I don't need this. Like, you might need this at Google. It could be useful, right? And then, of course, different communicative expectations. Communication is important now. There are a lot of jobs out there, but if you want the good ones, if you're going to get a good job, you need to be able to communicate well, not just code, right? So, this being Georgia Tech, we do have a writing and communication program, which is actually the program that I am in within the School of Literature, Media, and Communication. And instead of just teaching writing, we actually teach what we call, multimodal communication. So instead of writing, we look at the written, oral, visual, electronic, and nonverbal, right? So keep this in mind, because I'm going to take you through some of the deliverables that we do in our class and which of these modalities that it fits. And the aim of this is to make what our students learn in class more applicable to what they might be doing out in the world, because it's not just writing and it's not just coding, right? So the first semester of this class, the project design segment, pay no attention to the course numbers, they are confusing even to me. It starts out with, of course, a project bid, ongoing communication with their real world client once they have successfully gotten the project that they wanted, vision statement, user stories, which I think are the most useful one, and then everything up to having a final prototype where they do some usability evaluation. Second part of the class, there's a lot more deliverables, but they tend to be, kind of smaller. This is basically implementation where when we have them do things that are supposed to help them get their project done. So we have them do things like retrospectives, and then of course at the end we have a public expo, right? And I want to just focus on 2 of these assignments in, kind of the last things that I look at today. The team retrospectives that we have them do, in that part of the class, we break up the class into 5 3-week sprints, and we actually walk them through a very specific prescribed retrospective method after the end of sprint 1. We do a hot air balloon method, which we did not make up. We walk them through that during the first one. We actually walk around the room as they're doing sticky notes and all these other things and make sure there's no fights, right? They do it on their own for sprint 2, and then we encourage them to do that for the rest of their sprints, but we don't require that. We make them focus on team process, and then we actually have them kind of write up the results in a memo that they send to us, which is, again, another form of communication that we think is useful, could be useful, for them to do. Right? What we have found is that the retrospective itself is good because it's used in industry, obviously, but it also really aligns well with critical thinking methods, like just in terms of like teaching, right? So this we have found to be a really, really great assignment. The other kind of component that I just want to take a slightly closer look at is this like expo that we have the end of the semester. We implemented this last spring. So when I say that we change things, like we change things in April, right? That we've kind of added. And what we have students do here is we're actually attempting to replicate what would happen when they have to talk to other people, like about their code. Because what we've also seen with the advent of technology is students are very comfortable texting, they're very comfortable doing everything through computer-mediated ways, but actually talking to other people, especially strangers, and in a very short, compact way, not as easy to do. So we actually walk them through it, and we have them go through these different elements. We have them do everything from table staging, and sometimes staging is like using brochures in very pretty different ways to make your table look pretty. We have them do an elevator pitch. After the elevator pitch, we have them go into a no more than 2-minute demo, which would be like the first segment of a demo, right? And if you could hook people in on that, can you then keep them for the rest of the demo? And we have them come up with what we call, that one is always slow to load, distributable collateral, so something they can hand out and send people with. So the idea is lure people in to your table with candy or donuts, if need be. Tell them about your project, show them your product, and then send them away with something. And all of this happens very quickly. And just to give you an idea of what our floor plan looks like for the expo, that is the floor plan. We had 2 sessions of 30 teams each, so we had 60 teams, 300 students participating in the spring, right? In closing, I just kind of want to leave with from my perspective, the kids are all right in a lot of ways, and I have evidence of this. My students built that. Thank you.